In this lesson, we're going to talk about many of the built-in data types used in Python and a couple of the built-in data structures that are part of the Python language. I don't mean for this to be a comprehensive list either of data types or of data structures. This is just an overview of the more common data types and two of the most common data structures that you'll be seeing in the course and that you use in Python programming. We're going to use the interactive shell for this lesson, so let's go ahead and load it. So we type Python, and that loads the shell. First thing I want to show you how to do is how to clear the screen. And that's always operating system specific because every operating system has its own command for clearing a command line screen. So to do that, we need to import a library called OS, which will give us access to Windows commands. So once we've typed import OS, then we can issue a system command from that library. And so by typing os.system, open paren, open quote, CLS, close quote, close paren, we're just typing a CLS command to the window, and that clears the screen. You'll notice it also returns a value, but we're not interested in the return value. So that's how you've cleared the screen. And once you've imported OS, you don't have to do it again. So for example, I can put a couple of things in here that I can say, and the screen's cleared. All right, so the first data type we want to look at are numbers. One of the nice things about numbers is that you can use the different types of numbers interactively. So for example, I can mix integers with floating points. But first, let's just look at some simple examples. So 1 plus 2 is 3. That's simple enough. 2 times 3.14159, or pi, is 6.28318. So here I'm clearly mixing floats and integers and not having a problem doing so. Now, you can do that in other languages, but I don't have to have a specific type. And even if I declare variables, so for example, if I say num is equal to 2.1, I can say num is equal to 2. Python has no problem switching to a floating point type 2.1 to an integer type 2. So in that respect, Python doesn't recognize types in the same way lots of other compiled languages do. Python also makes it easy to work with big numbers. So if I raise 2 to the 100th power, I at least get an answer and not cause the system to crash. So that's how numbers are represented in Python. We're not going to do a lot of numeric programming in this course, so we're not going to worry too much more about numbers. A string is any character surrounded in either single quotes or double quotes. Notice that even though I typed double quote string, double quote, it still brought it back to me in single quotes. We can assign a string to a variable. Let's print it this time. Not that it makes any difference how we do it. And there it prints the value that's stored in str, which is string. Strings are indexed like an array. So I can type str sub 0 and get the first letter of the string, which happens to be S. I can also do a range starting at the first position or the second character through the end by typing a colon and then closing off the bracket and get all but the first character of the string, which is a nice little shorthand. Another data type that we'll use quite a bit, although not directly, a lot of times is Boolean. So Boolean is just a true or false value. However, you can't use it the same way you use, say, Booleans in Java. You can't type flag equals true. What I can do is I can say flag equals 100 less than 1. And then the value of that expression, 100 less than 1, a Boolean expression, false, is stored in the variable. Most of the time we'll be using Booleans as we test for true or false values and in decision making with if statements. Moving on to data structures, the first of the data structures we're going to look at is the list. And the list in Python is much like an array, or it's used in the same way as an array in other languages to store multiple values in one name. So for example, if I want to store the first 5 integers, I can write a list, which means an open bracket followed by a comma delimited grouping of data, in this case numbers. And now those numbers are stored as the list. I can just type the list back out, the name, to see what's in the list. Lists are indexed like arrays, so I can write numbers sub 0 plus numbers sub 1 to get 1 plus 2, which is equal to 3. So for those of you who are used to arrays, lists are very similar. As we saw in the first lesson, I can also loop through a list using a for each loop or a for in loop. So I can say for I in numbers, print the value in I, and it prints 1, 2, 3, 4, 5. So you see that lists are similar to arrays, but are much more flexible. There's a lot more you can do with lists in Python than you can do with arrays, even vectors in C++, for example. If you're familiar with symbolic programming languages like Scheme and Lisp, lists are flexible much in the same way that Lisp is and Scheme. The second data structure we're going to look at is the dictionary. And dictionaries are used to store key value pairs. Let's say, for example, I want to store a list of phone number extensions in an office. I can do that by creating a dictionary. And a dictionary is noted by using an open curly brace to begin the first part of the dictionary. Then I write the first key in quotes, followed by the value that's associated with that key. So for example, here we're saying that Bob has the extension 322. Let's do a couple more. Mary's at 110 and Joe 222. Then I close the dictionary by typing a closing curly brace. Now if I want to pull data out of the dictionary, I can do it by a key. So if I want to see Bob's number, I just type numbers sub Bob, and it returns the key that I'm looking for. Let's do that with Joe, just for another example. So there's Joe's number. So there's examples of two common data structures in Python, the list and the dictionary. One last thing I want to talk about before I move to the next lesson is one more thing about strings. Strings, as I mentioned before, can be written with a single quote or a double quote. So for example, if I'm trying to create possessive of a word, mics, notice the problem using single quotes. The first single quote indicates the beginning of the string. The second single quote represents the end of the string, but I still have that S out there. So if I want to create a string that has an embedded apostrophe, for example, I can use double quotes to surround the string and then a single quote where the apostrophe is to get the effect that I want. So that wraps up this lesson on data types and data structures. Now we're ready to move to the next lesson where we begin our look at control flow structures by looking at how to make decisions or selections using the if statement in Python.